Welcome back everyone to our calc series. Today we are moving on to chapter 4, which is all about contextual applications of derivatives. So in chapters 2, 3, we've talked about what derivatives are, and now we're going to apply them in real life situations and solve problems. So to start off, we have sections 4.1 through 4.3. These are about interpreting the meaning of the derivative in context. So you're given a context, you're given a function, and you want to find the meaning of the derivative given this context. So the derivative of a function, f prime of x, can be seen as the instantaneous rate of change of the function of f with respect to the independent variable x. So f prime of x is the instantaneous rate of change of f of x with respect to the independent variable. And this is all that we've been doing till now. And the unit of f prime of x is the unit of f over the unit of x. We're going to start here with two basic examples. So here we have Wt, W of t, representing the amount of water in a tank, let's say in liters, and time in unit of minutes, let's say. So one way we could interpret this is that, so Wt we know, and so one way we could interpret W prime of t, or the derivative of W, is the instantaneous rate of change of the amount of water in a tank with respect to time, right? So this is the instantaneous rate of change of the amount of water in a tank with respect to time. Notice we can put this with respect to with anything. So like this could be with respect to let's say height. It could be with respect to sunlight. It could be anything, right? But here we're being specified that it is time because t is the independent variable. Okay, and then for f of t is the amount of cars in a parking lot. If we consider f prime of t, that is the instantaneous rate of change of the amount of cars in the parking lot with respect to time. So that would be, I'm not going to write that down. And let's say the unit of t is, let's do hours. And amount is just a number, right? Uh, Now we want to find the unit of w prime t and f prime t. So these two guys, we want to find their units. So w prime t, its unit is the unit of f over the unit of x. So its unit should be the unit of w, which is minutes, which is liters, per the unit of x, the independent variable, or in this case t, which is in minutes. So the unit of w prime t is L over minutes, liters per minute. And one way we can think about this intuitively is W gives you the amount of water in the tank, right? Um, Volume. And W prime t tells you how rapidly this water amount changes. And that would be how many liters per minute. Okay, so then for f prime t, the unit of this would be the unit of f, which is some number over hours. So that would be the unit of f. At this point, I'm going to interject some necessary content. This is from 4.2 and 4.3, and this is about one specific contextual application in terms of position, velocity, and acceleration. And what's so special about these is that they are closely related by the derivative. And I'm going to assume that you've somewhat covered this in physics class. At least you know what position, velocity, and acceleration are. If you don't, please search it up because it's quite complicated to explain from the very beginning. So one thing that we'll notice is that Vt is equal to x prime of t, or the velocity is the instantaneous rate of change of the position with respect to time. So, or let me write that down. Velocity, the velocity at a given point is so x prime of t, if we were to interpret this, it would be the instantaneous rate of change of, now what does x measure? X measures the position with respect to the independent variable in here, which is t, with respect to time. So v equals x prime t. This is one very important relationship between velocity and position. Now, furthermore, we have a relationship between acceleration and velocity. So acceleration of t is equal to v prime of t. Acceleration measures the rate of change of velocity with respect to time. So sort of this goes more and more derivative. So this is the, or in the terms of orders, this would be the first order derivative, this would be the second order derivative. So this is one very important relationship that you are required to know. Okay, so now moving on to some real AP FRQs. Notice this section is specifically tested in FRQs. You'll sort of receive the same type of problems as here, and so it's really important to look at some examples. So back in video 2B, we talked about estimating derivatives, so this would be a nice review. Some of these might even be from that video. And we're going to focus especially on units of measure and interpretations, right? Okay, so here we have approximate C prime 5 using the average rate of change over the interval 3 to 7. So here they're being really nice. They're even telling us what to use. Usually we have to pick it ourselves. But here we can say C prime of 5. Remember, this is approximately equals to, not equals to, C7 minus C3 over 7 over 3, minus 3. And that would be 69 minus 85 over 4. This evaluated would be negative 16 over 4 equals negative 4. Okay, now we have done the first part. We have approximated C prime 5, and now we want to show, we have already shown the work, right? That's why it's always important to write in steps. And now we want to include the units of measure. So the unit of C prime t in general is just the unit of C, which is degrees Celsius, over the unit of the independent variable, which is t. So that's going to be degrees Celsius per time, and time is measured in minutes. So degrees Celsius per minute. This is the unit of C prime 5. And one way to do it is you can just attach it right over here, int, so as to indicate the unit of measure. Okay, also just for intuition, if you think about this, C gives you the temperature in degrees Celsius, and C prime is about how fast this changes, which is in degrees Celsius per minute, according to the units given. Okay, perfect. A student reads a book at time t equals 0, and R is measured in words per minute. R is just the rate at which she reads, right? Okay, perfect. Then R prime 1, again, we approximate here. They're also giving us the interval is approximately equal to R2 minus RO over 2 minus 0. So that's going to be 10 over 2, and that's going to be equal to 5. Show the work that leads to your answer. We've done that. Indicate units of measure. So these are sort of the more modern ones, and they only ask for unit. And that's sometimes good. So R is words per minute. So this is the unit of R. So let's first put that down. So the unit of R is words per minute. And the independent variables unit is minutes. So we have minute again. So this R prime 1, the unit of this is words per minute squared, like this. This problem here is not exactly related to our topic, so we'll leave it for self-practice. But notice how this here, cubic feet per hour, being the rate at which snow accumulates, and how g of t being removing, connects to the rate of change of volume of snow. So this is more of a calculation. It's more of a review of what we've done previously, calculation. You just need to note that the rate is just equal to f plus g, right? The rate of change would be how much accumulates. Oh, sorry, minus how fast it gets removed. So like the rate is the rate at which things get added minus the rate at which things get lost. Good. And notice this is t equals 8. Okay. Here, approximate r prime prime of 8.5 using the average rate of r prime over this interval. So again, this is some really easy stuff. And so here we have the calculations. And for the unit, again, it's the function that we're taking the derivative of, in this case, r prime, right? We're taking a second derivative of this, of r, one derivative of r prime, over the unit of the independent variable. So one trick is that you can just look at the table, the first part of this table, and you're taking this over this, right? So that would be really quick. So that's cm per day squared. Okay, again, if you use the same trick, you can save a lot of reading time, at least for the first question. In the end, though, it's still best to read it because you'll have relatively okay time on the FRQs. So again, estimation. That gives 4 over 0.5, that's 8. And the unit of this would be the unit of f, which it already gives here, milligrams per square centimeter per centimeter. So that's going to be milligrams per cm cubed. Okay, so that is everything for today's video. Just for a recap, we talked about how to find or how to interpret the meaning of f prime of x, but in recent years, the most important part currently is to know how to find the unit of f prime of x using the unit of f and the unit of the independent variable x. We also talked about position, velocity, and acceleration, and just look at these problems again to get yourself familiar with this type, because this type will almost certainly appear again on the APs. Thank you.